All right, we're on the air now.
Sounds good. So I was asking about question 3, if I understood it correctly. It says use the normal probability applet to find the combined area. And it gives you the z-score of 1.358 and negative 1.358. And which means they want those two sides highlighted, correct?
Right.
And then it gives you the area, and so I added the area because it's supposed to be, I mean, based off looking at the video of going over a similar problem like that on the preparation assignment, he calculated the area, so he just added, so you get 0.1745, and you added that together. So that's what I did, and I got 0.349. Am I off base on how to do that one?
Combined area.
Right, underneath.
Mm-hmm.
Because that's what I mean, like the normal curve. And the normal curve is underneath, like where it's white, not where it's highlighted blue, correct?
My understanding is that just both the sides need to be highlighted blue. The middle is white. And yeah, like you said, it was 0.1745. I think just that's the answer.
That's what I understood it as.
Because I don't think it's asking for anything else. Let's see.
Because you just want the area that's to the right of the positive 1.358 and the area to the left of negative 1.358.
So it's not asking to add or anything. That's why I'm like thoroughly confused.
Well, if you add them together, so it would basically be 0.0872 plus 0.0872, which gives you the 1745.
Oh, okay. So yeah, so I totally misunderstood that.
So rounding would be 0.175.
So yeah, 1.175.
Everyone good with that answer for now?
Yes, yep. I'm just trying to
for round 1 at least.
So question 4, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of individual observations X, the distribution of sample means X with a line on top of it, or this cannot be determined with the information given.
The following will have a smaller standard deviation.
I'd say the distribution of sample means.
That makes sense based on what we've been learning, but I almost feel like it's like this cannot be determined.
I'm kind of confused. I'm just, not sure, because I kind of feel the same way. Like, I don't know if it's me that doesn't have enough information because I'm not understanding. And I'm being totally honest because I don't think our teacher's going to deduct us for being honest about not understanding stuff.
Yeah. 9 observations are randomly drawn from a population, because I feel like it doesn't even like, how are you even supposed to know what any kind of standard deviation is?
Well, all I know is, so 9, you have 9 observations.
Right.
You have, the mean, whatever the mean would be, this is like, I don't know how to explain it. I just feel like the distribution of sample means X, just because I feel like that's in the reading.
Okay. I'll glance at that real quick. I just want to.
The only number we've been given is just the 9. X equals 9.
Right, the observations.
Okay. Okay. I'm reading. Okay, so for the mean of draws from a random variable with mean and standard deviation, the following are true. The mean of a random variable X is little U-shaped, and then the standard deviation of the random variable is. All right. I mean, if you're pretty sure with that one, because I'm unsure. That's pretty much what that answer is. Is like I don't think that there's enough. We can go with the distribution of sample means for this one.
Okay. I like that because like I said, I don't know if it's me that doesn't have enough information because I'm not understanding, or if it's not providing enough information.
Yeah, and we have 2 tries, and so neither of us really, or none of us really think that it's the first one, right?
Right.
Oh, definitely not.
Okay. I mean, so yeah, it's a 50-50 chance at this point. I mean, let's move on.
Okay.
Which of the following result implies that the spread of x decreases as the sample size increases? The normal distribution, the 68, 95, 99.7 rule, central limit theorem, or the law of larger numbers.
So the spread, is the spread supposed to be like the shape, isn't it?
I would think so, yeah.
I'm just trying to remember where I wrote it down. Because I feel if the spread decreases as the sample size increases, I want to say, wouldn't that... I mean, I know that's the central limit theorem or the law of large numbers.
Yeah, I don't think it's the 68 because that all has to do with the
probability.
Yeah, that has to do with the standard deviation.
Like, yeah, so many standard deviations away from, right? The 68, 95 is the amount of standard deviations away from the mean, correct?
Yeah, that's and then based on that, like the percentages. So
that doesn't sound like that's the answer to that question. Implies.
Well, here's what I have for the law of large numbers. The greater amount of observations in our sample, this sample mean x draws closer to the population mean, or as the number of repetitions increase in an experiment, the proportion of an outcome observed gets closer to the probability of the outcome.
So if I don't think it's that, I don't think it's the law of... I think it's that one either.
Well, x with the line over it usually means the mean, right?
Right. Well, no, x is a random variable. That's the weird U, like reverse U thing.
Oh, gotcha.
That one he's saying is the... My brain's not working properly to have...
X with a line over it.
Out of my mouth, sorry.
X with a line over it is a sample mean.
Okay.
And then the population mean is just like the U.
I don't think that had anything to do with the law of larger numbers.
I don't know. So
we're saying that the x with the line over it is the value, correct? If I'm understanding the reading correctly.
X with the line over it is the sample mean that draws closer to the population mean. So it would be like a random number essentially drawing closer to the actual mean, I believe. Because x can be any number.
Mm-hmm.
And then like the mean's usually set and they'll give you whatever the number is. And all I know is with the large law of large numbers is that the more observations you do, the closer the probability should be to the outcome. So like, it would be like I feel like it would be like a right skewed. Like it's supposed to get closer and closer and closer.
Mm-hmm.
I'm kind of leaning toward the central limit theorem, but I don't have the definition here.
Sorry, I accidentally turned my camera off on accident.
Oh, you're good.
The distribution of sample means is normal when the x with the line over it is normally distributed, or when, thanks to the central limit theorem, our sample size is large. That's what central limit theorem is. So maybe
I would honestly say it's central limit theorem, maybe the normal distribution, but I'm really leaning towards central limit.
I don't think it's what was the first answer? The normal distribution?
Normal.
Because of this line right here in the reading, it says to compute probabilities even involving the sample mean x with the line over it, we must first determine if x over the line is normally distributed. If not, we cannot compute possibilities.
Right. So then I would say central limit theorem, because the law of large numbers, I feel the x, like the sample size should decrease with it.
Mm-hmm.
So the sample size shouldn't get any larger. Or no, wait. Maybe I'm just like misunderstanding this. So as the sample size gets bigger, the spread decreases.
yes. That's what it's saying. Which of the following implies that the spread decreases as the sample size increases?
So perhaps it is the law of large numbers. I don't know, guys.
It could be a different way of saying what the law of large numbers is, because it just...
It could be a smarter way of saying it. I'm not that smart.
Well, like, and maybe more understandable, because the way it's written in the book, the definition in the book, we'll say the definition. I'm using that term loosely here.
Okay.
Doesn't make sense to me. But you put it like this, results that the spread decreases as the sample size increases. That kind of makes sense.
I'm good to go with central limit theorem. I think. Yeah. I think that's.
Well, I'm tossed between that one and law of large numbers. Just
for the sake of time in our brains, I think we should move on from this one. I don't think that this would.
Yeah.
I mean, even dealing with any numbers, you know.
I'm going with you on the central limit theorem.
They'll get lost.
I'm good
All
with
right.
that.
Use the following.
What, Nick?
What?
Did you say which you were?
I'm going with the central limit theorem.
Okay.
So.
Well, we can always. I mean, if it's wrong, we fix it. Because the other two definitely don't.
Yeah, I agree.
Okay, so 6, we have to use this information.
For 6, 7, 8, and 9, we use the information.
Scores on the quantitative portion of GRE are approximately normally distributed with the mean of 150.8. Excuse me, and a standard deviation of 8.8.
So for question 6, I got 1.045 rounded.
Let's see.
And scored of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Okay, so just help me remember. The z-score would be what she scored minus the 150.8, correct? Divided by 8.8.
Right.
See? So I did learn something so far this semester.
Yeah, I got 1.045 repeated for the 4.5.
I haven't calculated it out yet. Give me a minute.
1.045.
Yeah.
Okay.
I'll tell you what I calculate. Make sure I didn't make a mistake here. $1.05 and it says around, so it'd be 1.045. Correct?
Are
Right.
we good with that? 1.045 as our answer?
Yep.
Yes. We all came to the same answer. I mean, so
Yep.
if it's wrong, we all got it wrong.
All right. What is the probability that a randomly selected student will score above a 160 on the quantitative portion of the GRE?
I got 0.148.
So we would just put in the z-score, correct?
Yeah, you put in the z-score and then just highlight the section that would be above 1.045, or yeah.
So you said 0.1480.
Well, since you're just rounding it to 3 decimal places.
Okay, yeah, so 0.148.
Yep, I got that.
Because you put in the z-score and it's above that, so that would be above the 1, the positive side.
Because the 1.045 is the equivalent of 160. If I remember correctly.
I was piggybacking off, like, we already answered what the z-score was, and you have to get that to get the probability, which is the area answer, also using the normal probability app, correct?
Right.
Okay. Just making sure. I may sound like I am.
Thank you.
I hope I don't sound too redundant or whatever. I just want to make sure, like, I'm understanding things.
You good. Question 8's a fun one.
Yeah, don't tell me that. A random sample of 5 students were selected to take the zero. Their scores are. Huh?
So my understanding is we got to add those up divided by 5 to get the mean.
Okay.
Well, it wants what is the z-score corresponding to the sample mean?
Right. So we got to get the sample mean, or we got to get any kind of mean. So we got to add those up.
So 160 plus 175 plus 163 plus 149 plus 153, and then
right.
800 exactly, and then divided by 5.
800 or 805?
Oh, I got 800. Sorry, let me do it again.
Okay, I haven't quite gotten that far. I just was. My brain is slower than you guys are moving, so just saying.
Oh, no, you're right. 800. I must have done something wrong.
So did you get 800 when you added them all up, Kim?
Yeah.
I'm still adding. Sorry, my brain's working much slower than you guys. I'm sorry.
Okay.
Yeah, I got 800.
All right, and then divided by 5.
160. So it's 1.045. Am I wrong? Did it totally trick us?
Well, what is the z-score corresponding to the sample mean of these students' scores?
Well, the sample mean is 160. Because 800 is the number those added up. Divided by 5 comes to 160. Wrong?
Right.
So isn't it just going to be the same as number 6?
That's what I was just trying to figure out myself. Throwing a little trick ball in there.
What do you think, Nick?
I have no idea. I'm completely fine with going with that.
I mean, let me random sample of 5. Because that's how I understand it, is that you got to have some kind of mean from there. So you add them all up, divided by 5.
What if it's different? So what if it's 160, okay?
Uh-huh.
The 160 minus the, what was it, 150.8?
0.8, yeah.
Okay. And then what was the deviation? 8.8?
That's the same exact question. And
yes, but just follow with me here. We have a random sample of students as well, which is 5. And so your equation should be 160 minus 50.8 over 8.8 divided by 5, or the square root of 5.
Oh, okay, yes. Okay, the standard deviation divided by the square root of the sample mean.
Which, for that, I get 2.37, or 2.337.
Okay, so hold on. So it's 160 minus 150.8. So I know I was finally able to follow your thought process there, because it's the 8.8, which is the standard deviation, but then it's 8.8 divided by the square root of the sample mean, which is 5, correct?
Right.
See if I was able to actually follow that. So this is how, like, I understand why that's set up that way, but I don't know why I'm drawing a blank on how to calculate that out on my calculator.
Yeah, so I got 2.3377, so 2.338.
Mm-hmm.
That's what I have for my answer. Because that would be the z-score corresponding.
That makes sense. I just don't.
Hold on, I'm trying to find the square root button on my calculator on my phone.
What actually helps me for my phone, I have this app. It's just calculator plus the number sign on it.
Mm-hmm.
And it's like really good for a lot of different things. I can do like algebra stuff. It has an algebra mode on it, so it's like my go-to app.
Well, see, so this is the calculator on my phone. I'm going to turn it around so you can see it. I don't know that you can. Oh, you can't see a black screen from a black screen.
Is this the one that you're using? Let's see.
Yeah, I mean, that's what I'm using. I know if you like turn it sideways, you can have like the scientific mode.
Oh, gotcha.
Right, I don't know which one's the square root button. I know that.
That's what I was trying.
I hated that. So let's see. This app right here, you can see that.
Yeah, I can see that.
That's just what it looks like.
Calculator something.
And it ends up looking like this.
Is it that one right there? The one that my finger's on? Is that the square root button?
I have no idea.
Yeah, I don't know either. I'm gonna try looking for that real quick.
Let's see.
Calculator app? Calculator. Nope, that's what's on the phone.
So yeah, type in like the search bar for the App Store calculator and then the number sign.
Oh, oops. Not the game. Come on.
Yep, I'm downloading it right now.
I found it and I clicked on the wrong thing.
I'll tell you, it's been a lifesaver, and you can actually buy the app for like, I think it's like $2.99, and it has a few other features that are available when you do that.
Alrighty, so let's see, it was 160, right? Minus 150.8 divided by Wait, so when you did that calculation, did you get like 92.5 something and then?
No, so this is how mine's laid out.
Oh, gotcha. Oh, sorry, I forgot to do the 8.8. Yeah, sorry.
No, I don't. So 160 minus 150.8. Oops. I'm about to drop my phone. Let's go away. Equal. Divided by 8.8 divided by
And what did you get, Nick? Like 2 point?
I got 2.337707, so on and so forth. which when you round it's 2.338.
Okay. Yeah, I did it a different way, but I got the same thing. I don't know if you can tell. Or sorry, where's my answer?
I can see. I'm still trying to, like, I understand how it's set up that way and why it's set up that way. I just can't figure out how to input it in my calculator.
So the way I do it, if you have the app that I have, is
Yep, I just downloaded it.
You can swipe from the right to the left, and you'll see that there are a couple buttons about in the middle that show fractions.
Yeah.
Yeah, so I'll hit the single fraction because you don't want the one that has a whole number in front of it. And then if you hit that one, you hit that, and then if you go back over here and you just kind of push the arrow till you're in the bottom box, you go back and then hit the fraction again. And then you can go back up and input all the data that you need. Otherwise, a shortcut is if you're on the main page, just hit Shift, and then where the division sign is, shows the fraction as well. And then you input the data, and then when you're in the bottom, in the denominator box, just hit Shift, and then put another fraction in there, and then input the data.
So I'm good with trying 2.338.
I am too. I just, my husband will be able to help me better understand this stupid.
No worries. Question number 9, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? I believe that's just inputting that 2.338 into that probability. Then the greater blue side, or the right side, far right highlighted blue, was 0.0097 for the area.
I got that. Makes it pretty small.
Yeah, like really small.
Yeah.
Point.
You don't have to round any of those numbers. It just goes to the 4th place.
Is that what it asks for? Is 4?
Round your answer to 4 decimal places.
Yep.
So 0.0097.
Yeah.
0.0097.
All right, let's do this. These next ones.
We're more than halfway done.
Yay.
Suppose the mean GPA of BYUI students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected? Is it left skewed, right skewed, approximately normal? We cannot determine given the information.
Approximately normal.
You think normal, Kim?
I do, because of everything that we messed up on last time. The side, like, if it's because of the central limit theorem, I think is the one. No, I mean, like.
Oh, the law of large numbers. You know, like anything greater than 30.
Well, it's something about the distribution of the sample means is normal, but it's the sample size gets larger. So I'm just misunderstanding which one it is. It doesn't. We don't have to answer that right now, but it's. I believe it's approximately normal because if the sample size is larger, it's going to appear more normal as opposed to with a small sample.
What are you thinking, Nick?
I am thinking I have no idea because I can't do an equation, like a full equation, without like a different number as well, because you have the mean, you have the deviation, you have the number. Yeah, I don't know. When I input the data, I get 45. So 35 divided by 7, which is divided by the square root of 81. And so that's a big number. I'm okay with approximately normal.
What?
We just go with normal. I'm fine with that.
What is the mean of the distribution of the sample means, sampling distribution for all possible samples of size 81 that can be drawn from the parent population? I would say it's 3.5.
Because yeah, that's the mean.
And the mean is the same as the mean of all sample means.
Of all, like, to the parent population. Yeah, I remember in the video, it's like that, and then it had like a little X as like a subscript.
Yeah, so it's like the mean, or I don't even know what the actual name of that thing is. I know the one with like the circle with the line over it's a sigma.
Mm-hmm.
But yeah, it's whatever that is with the little subscript of X equals the same as if it was just U. That weird fancy U thing.
All right, so 3.5.
3.5.
Now we're rolling.
What is the standard deviation of the distribution of sample means for all possible samples of size 81 that could be drawn from the parent population? This one's trickier because I know it's not 0.7.
Well, it's the whatever the value minus the mean divided by the standard deviation.
I don't think it's that, because it's just the standard deviation, which the standard deviation should be the standard deviation divided by the square root of whatever number.
So is it just 0.7
divided by the square root of 81?
Which is 9.
And that comes up to 0.07777777.
Yeah. Yep.
It's what?
So basically it's 0.078.
0.078. Sorry.
Right, 0.78.
0.78. Just 10 after the decimal.
After the decimal. Yeah, because it's the sigma versus the square root of a number.
Wait, yeah, so it should be 0.778.
Oh, 0.077.
Oh, sorry. No, yeah, I did just 7, sorry, instead of 0.7.
So is it so lost?
So 0.078.
Okay, 0.0. Okay, there's a decimal point between the two zeros. I'm following now.
All right. What is the probability that the mean GPA for 81 randomly selected BYUI students will be less than 3.3?
Okay.
So
I got negative 2.57, 1 for the z-score.
Okay, so let's see.
Okay, wait. What is the probability that the mean
So the answer I would get is 0.0051.
So did you do 3.5 minus 3.
I did 3.3 minus 3.5 since 3.5 is the mean.
Right.
3.3 is what we were given.
Okay, so 3.3 minus 3.5, just so, and then divided by the standard deviation.
Divided by 0.7, which is divided by the square root of 81, or 9.
And
wait a second. I take that back. It is not the 0.051. It's asking less than 3.3, not negative 3.3.
So it is still 3.3 minus 3.5 though, right?
Right, it is.
Negative.
So yeah, just whatever you get, you enter into the normal probability applet. And then you want to figure out the probability of selecting a student, one of the students whose GPA would be less than 3.3.
I don't know what I'm doing right. I don't.
So Kim, did you get
the? That's why I figured out if you can. I don't know if you can see it.
Yeah. So what I want you to do, Kim, if you can see this.
Okay, see, that's what I'm trying to figure out how to do it that way, and it's not.
So you see the shift button at the top
I see the shift
left
button
corner. So underneath says AC, so hit AC first. So it clears off your screen. And then hit shift. And where the division sign is, there should be little boxes. So click on the boxes. And then in the top box, put in 3.3 minus 3.5.
Got it.
Now in the bottom box, just put 0.7. And then hit shift and hit that same division box again. And then above the 9 is the square root symbol. So hit the square root, 81, or you can just hit 9. Yeah, just like that. And hit enter or equals.
Okay, so I was off because my calculation was not correct. Not a big deal.
So then I'm looking back at it. So it was like negative 0.57 or whatever, 5.6.
Yeah, so negative 2.571 is what I have.
Okay.
And that gets put into the z-score spot, correct?
Right.
And
then you want to highlight, once you've inputted that, highlight everything that would be less than the 3.3. So basically everything that would be less than positive 2.571.
So that would be everything but the really small section on the right.
Right.
So that is 0.9949.
Right. That's what I got.
I got that too.
And then for 14, it asks what will be greater than 3.3, which is the other half of that. And then make sure you round it to the third decimal place.
So for the answer on 13, is it just 0.999?
No, it's 0.995.
Yeah, 0.995.
And then the 0.005 would be the answer to 14, I believe.
Yeah, everything else. So
you just change the probability app to be the other side, the small side above, right?
Yeah, so I mean, you could go back to the app and then just click that one spot and unclick the other two. Or if you were to just take one and then minus the 0.995, you get your answer.
Hello, yes, it wasn't like, now that you say that, that makes sense. So, one, let's clear AC, one, and you said 0.005.
all right, the last one.
Hold on, I've got to. Okay. United States Coast Guard assumes the mean weight of passengers of commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds weight. Out of a random sample of 48 commercial boat passengers are recorded. The sample mean was determined to be 77.6. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than is observed in the sample.
This is a fun one.
That didn't make sense to me. I'm sorry. Are you laughing because you don't understand either, Jacob?
Yeah, I'm like getting burned out on this. So like trying to.
So, yeah.
Find the probability that a random sample will have a weight that is as extreme or more extreme, either above or below the mean than was observed in the sample.
So, do you think it's just saying like to do the 177.6 minus 185 divided by the 26.7 divided by square root of 48?
I guess, but 48. I feel like I don't know the weights of the random sample of 48 commercial boats. Yeah, I mean, let's try that.
So 177.6 minus 185 divided by 26.7 divided by the square root of 48.
Which I get negative 1.920.
Okay, sorry. I'm gonna type in here. Let's see. Shift 177 -6 minus 185 shift, and we've got 26.7 divided by 48. You said, did you say negative 1.920?
Yeah, that's what I got.
Okay. Based off that calculation, I got the same thing because I remembered what you said to do. This calculator app will probably do me some good the rest of this semester at least.
You got negative 1.92, right?
Yeah.
Okay.
Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than was observed in this sample. So I believe that's just inputting it into the probability applet.
Mm-hmm.
So
and it wants it to be
97.26. So 0.973.
right, because that's all greater than. I mean, more extreme to me is, yeah, everything to the right of that line from your negative z-score.
Yeah.
That makes sense to me.
Moment of truth.
All right. So what do we? Sorry, what was the final?
0.973.
Okay.
Are we all doing this?
Might as well.
Are you sure you want to submit?
I'm gonna do it.
You are about. Are you sure? Yes.
13 out of 17.
That's not horrible.
Dang it, we didn't get
It's like
5 right.
76.
Considering how, I'm being honest here, you'll learn that I'm a very honest person. Considering we were all pretty like, I don't know about this whole thing, that's not horrible. I mean, I know we can get it better. So 15 was not right. 14 was not right.
13, 14, 15 were all wrong.
Yep, so the last 3.
Which is weird because for 13, it says everything like less than 3.3. Unless that's like reverse. I don't know.
Here, I'm gonna write down my answers real quick.
Oh, I did that all along. That's one reason why I was a little behind you guys. So we got 5, 13, 14, and 15 right. Or wrong, sorry.
Right.
So based off of that, I'm going to say that 5 is the law of large numbers instead of the central limit theorem.
I agree.
Okay, yeah. So only 4. 4 wrong. Like I said, considering we were all very unsure if we only had one attempt. We don't have to worry about it. Okay, so I can go lesson 7 and start a new one.
Good call on the approximately normal one. Yeah, on 10.
Well, for some reason that's one of the very few things that's sticking in my brain. won't do me any good come test time next week, though. When I forget everything else and go,
Go is our first test next week.
Yeah.
The first half of the week, yes. And then we have a regular lesson after that.
What was I gonna say? I guess looked at like what like the project we have to do is really.
No,
Nope.
I didn't want to look at that yet. I want to get through my other class because it's only a half a class, I guess you could say. Like it's like I'll be done with that by the end of this month.
Oh, it's only first block.
Yeah. I only have 3 more weeks. After today, I only have 3 more weeks of that class.
That's nice. I wish I could say that about any classes I have.
Yeah,
Well, it's just that my major is the marriage and family studies, and this is the intro class to that. So that was a lot easier to this class. Distribution of sample names. I'm going back in and entering the ones that we do know. And we then need to work on 13, 14, and 15. And to go to 1.045.
Well, at least I got us right for that number 4.
Yeah, thank you.
And 8 and 9. Those ones are fun.
Yeah, good call on that one. So what I'm kind of looking at 13 right now. I'm trying to think of like what we could do differently.
Okay.
What was the mean on this one? 0.7 or something?
0.7. So the mean is 3.5.
Yeah, that's standard deviation. Sorry, that's what I meant.
Standard dev is 0.7. Random sample is 81.
Okay, what's the probability that it was the negative 2.57.
Here's a thought. What if instead of 0.7, what if you just divide it by the top portion? So let's see, 3.3 minus 3.5, and then divide it by just 0.078.
That's something different. You want to try that?
It is something different, but the only reason I'm saying that is because in question 12, you figure that out already. because it's the sigma divided by 81 or 9 or whatever, which, because of that 8, you get a different number.
So you're saying 3.3 minus 3.5 divided by 0.078.
So here, this is what you get with the 3.3
right,
minus
that was the
3.5.
negative 2.571.
And then this is what you get when you just do the 0.078.
Uh-huh.
And I'm wondering if that would make a difference, only because, like, aside from the actual, like, the 3.3 and 3.5, that's what you get when you just do the sigma and the number.
Okay.
So you're saying 2.564 negative 2.564. And that gives us a 0.0052. Is that what you're getting, Nick and Jacob?
Yeah, so you have the 0.52. The only thing is, though, you would still get the same. Essentially, you still get the same result, because if you round it, it's going to be 0.995 and then 0.005. And you have to round them to the third decimal place. So just ignore that then, because that's not right. The only thing I could think of is if by some chance they messed up and it's like the reverse answers.
Maybe that's possible.
I'll give that a shot, and I'll let you know if that's what I get. Any clue for 15?
No.
What was our... Do we not know our answers for 13 and 14 then at this point?
I don't.
Yeah, I can't come up with anything else or different either.
Because if you do it the way we originally did it or the way that I just thought of doing it, you get the same thing. Because you have to round it to the third decimal place, and you're still going to get the same digit for that spot.
Yeah,
If those end up being like the only two I get wrong, I'll live with it. $15, here's the tricky one.
Well, 13 and 14 obviously are tricky, or tricking us up this time.
Okay.
I may end up having to just take these last three and call it a draw.
I gotta go get my wife here pretty soon.
Yeah, it's almost 3 o'clock there, and it's almost 4 o'clock here, so I gotta go wait for the bus. Yeah. And typically my son's bus is quicker.
Like we didn't. I guess I could stop the broadcast. I'm gonna stop the broadcast.
Yeah, go ahead and do that.
Okay.